What I'm going to talk to you about is what I've been working on for the last 6 years or so with Russ since 2007, and that is these undergraduate double-star research seminars. So what we're going to go over is why students should do research, which many of you probably already know, but it's good to get a review. Quest to College and high school seminars that we did that were very successful, and then why we picked visual double stars, because we didn't start out with visual double stars. And then moving beyond San Luis Obispo out into the wider world, and then finally some advanced techniques very briefly to transition into Russ's talk, which is going to follow mine. So our mantra has been learn science by doing science. Actually, we've had several mantras like publish or perish, a few others, but the main deal is that in science, in classes, students usually learn the old scientific method. You make an observation, and then you develop a hypothesis, and then you test it, and all that stuff. Well, that is a very general truth, but there are a lot of subtleties and things that the students don't learn about by just doing lectures and lab science. Of course, there's a very strong place for lab science and lecture science, but certainly these seminars and doing real research is a plus for the students. One of them is, as I mentioned, publication. So these publications, when they get into a journal, really boost their careers. It looks good on resumes and other things, and it prepares them for later work on master's theses and doctoral dissertations. Not that I have any personal experience of that, but that's what I hear. So this is just a few of our students from over the years that have gone through the program. So we started out, actually Russ started the program in Arizona a number of years ago. I think it was in the late 90s. Is that right, Russ? Yeah, over 10 years ago at least. And it was primarily focused on variable stars, and those are pulsars, eclipsing binaries, other things. And eventually, long story short, Russ moved to San Luis Obispo, and he started working at Cuesta College, which is a community college. It's a very nice place. And he met up with Tom Smith, the fellow on the left, and they worked through some of the details of getting students together to do this research. So Russ and Tom and several students, I think there were 3 or 4 students, we have an Apple update. Awesome. Okay. So Russ and 3 or 4 students got together and started doing some of this research. In fact, we even had other projects at the beginning, an astrobiology project and some other strange things. But anyway, that semester went fairly well. It took a long time to publication for a lot of the articles, but we got through it, and we got to 2007. And this is actually the star party where I met Russ, right there. And so about a month later, I had finished my first project as part of the seminar, and I went on to join the other students in the class to do photometry of exoplanets and asteroids and a number of double star papers. So this was the first time that we started doing double stars. And what was really interesting about this particular seminar was it was really diverse in the number, or in the kinds of people that were involved. We had 6 high school students, 6 college students, and 6 amateur astronomers, local folks, and PhDs that were involved. So it was really eclectic as a group. And we used The Sky is Your Lab as our textbook. So thanks to Bob Buckheim. So following the success of those, bump to the second line there. Oh well. We took the seminar to Arroyo Grande High School. So these were going to be high school students taking their first college course. We have a couple of those students here with us, Bobby and Eric, wherever Eric is. So they were Arroyo Grande High School students, and they completed a number of double star projects over the years. And we also took the seminar to Coast Union High School. So we ended up with many, many publications in the Journal of Double Star Observations since our first high school seminar in 2007. And then it became almost exclusively high school students after that, up through 2012. So why is it that double stars were what we picked out of all those different possibilities? Well, the first thing is that there's really low-cost equipment. You don't need a several $1,000 CCD camera, which students often drop and break. So you just have a telescope and your eyepiece. This is a Celestron microguide eyepiece. That's the one that we mostly used. There are a number of reasons for that. First of all, it has more divisions on the linear scale, and it also has a little divide on the linear scale, so you can fit the stars right in the middle to see them really easily. And you just need a stopwatch. So this is a total of not very much, comparatively speaking. Which, by the way, is why we do astronomy anyway, or at least one of the reasons. If you want to do particle physics, you need an accelerator or whatever. So it's just generally low cost. Another thing is that the concepts involved are relatively straightforward. We use a little bit of Pythagoras, and at worst, maybe a little bit of Kepler. So it's not really rocket science. So we've had a number of students take the course who are humanities majors or who are students who aren't really looking for a career in the sciences. And they've been really useful, especially on editing papers and writing the papers for publication. Perhaps one of the main things that we get out of it is the students are exposed to real quantitative research. When they're in high school, usually they have to do term papers and stuff where it's all very literature-based. You go onto Wikipedia and copy and paste. But at least for these papers, they have to take averages, standard deviations, standard errors of the mean, your basic statistics, and they have to use your calibration equation for that linear scale to figure out how many arc seconds there are per division. So it's 15.0411 arc seconds per second times the cosine of the declination of a reference star times the time it takes for the star to drift across that linear scale, all divided by the number of divisions on the linear scale. So they have to do that one, which is really cool, and it usually looks really intimidating to them the first time they see it, so it's kind of neat watching them work through it. And then they move on to doing the Basilian epoch, so they learn a lot about different dating systems and that sort of thing. Basilian, of course, being just a decimal date based on our calendar year, so it'd be like, right now we're in somewhere around 2013.2 or 3 or so, probably 0.2. Anyway. Then also they can sometimes go on to calculate the distance to a star based on parallax, which is actually a slide I didn't put in that I should have, is that they get to use the catalogs as well, which is really big in science. So they go into the Sinbad database, find the parallax, and they can calculate the distance, which is a pretty simple equation, as we all know. So transitioning from there, they get to learn some of the basic astrophysics involved in not just double star astronomy and astrometry, but astronomy in general, such as finding the distance to stars. You've got proper motion, so these two stars are going in the same direction, so they're probably binary. And they get to learn a little bit about even spectral types. If you have an A-type star and a K-type star, and the K-type star is brighter and they're on the main sequence, they're probably not binary because the K-star would have to be a whole lot closer. All right. Another thing that they get to do is collaborate with a lot of the experts in the field. So we've got Kent Clark there, of course, in the upper right, handing out awards at one of our conferences that we did in San Luis Obispo. And then I'm working with Brian Mason down there at Kitt Peak on the 4-meter telescope. And then we've got Dave Arnold here on the left. Wait, I've been doing all these directions backwards, I think. On the right, Dave Arnold, who has helped us in essentially every one of our seminars. He's been a big help. He's always reviewed our papers and made many useful contributions. Oftentimes we include them as co-authors if they contribute a significant amount to the project, which is pretty cool. So the students get to experience that. And perhaps best of all, we get swift publication through the Journal of Double Star Observations, thanks to Kent Clark. So this particular issue, this is the current one, has 4 of our papers in it, which is kind of neat. These 3 right here are from this summer where we had a lecture course, and these were all students that seemed really bright on the first day of class. They all had their textbook on the first day, which was a good sign. So Russ decided that we should go ahead and turn it into a seminar. So we did, and we got a number of publications out of it, which was pretty cool. And But yeah, so one of the problems with the other papers, like the variable star papers, is you send them to the journal, and then maybe a few months later it comes back, and then you send it out again, and then it could be months to years until it finally hits the press. But with the JDSO, we've had a few of our papers come out during the seminar, which is really cool. So we really appreciate that. So, following the success at these local seminars around San Luis Obispo, we branched out into the wider world, such as Pine Mountain Observatory on the left. Those two pictures, top and bottom. We've done that for a number of years. We started in 2008, and it's gone through till 2012. We didn't do double stars there in 2012, but we hope to. Tom Fry and I plan to go back in 2013, I think, still, and start that up again. So that's done a number of things. One of them was actually going back to the astrophysics. On one of those projects, we calculated an orbit on the sixth orbit catalog scale, from 1 to 10, I think it is. This would be like a 13, so pretty rough, but hey, we did it, and the students learned a lot from it. And we also have done a few more. In the bottom left-hand corner is the Chico State students. Actually, not Chico State, Chico High School students. I went to Chico State, that's where I just graduated from, and I worked at a science museum where I had the facilities to start up my own seminar, which is kind of fun. So these were some of my students that I had. And above that is the one done at Victor Valley Community College in Southern California. That was led by a guy named Mark Brewer, who took the class a few years ago, which was great. I haven't been looking at the cards. How am I doing? Okay, cool. So there are a few keys to making these seminars successful that we've gleaned from our experience. One is that some projects are more amenable to a short time frame than others. So that being the double stars, especially visual double stars eyeball to the eyepiece. Seems to work really well. Another thing about it is that if you want to teach the students all the aspects there are to know about doing photometry, some of the students often get kind of left in the dark, and it turns into a black box project where they have some data, stick it in, and out pops an answer, and it's just voodoo. And if you want to get them to understand more, then it takes a little bit longer, and sometimes that can stretch out the project a little bit more. With the visual double stars, there's none of that, which is really good. We also have to require publication of research. It's not real science if it isn't published. I can't remember the guy's name now, but I remember Tom Fry at one of his talks at PMO talked about a fellow who made all of Galileo's observations, or at least a few of them, some of the major ones, and that was before Galileo, but he didn't publish them, so no one knows about him. I can't remember his name either. So, do you remember, Tom? Yeah. So, it's not science unless you publish. You have to have experts ready to review the papers. If they're not ready, they're just going to sit on their hands. So they have to be aware that the papers are coming at them, and they're always very gracious as long as they know what's coming. And they don't have to be double star experts either. You can send it out to other people. We almost always send our papers to Tom Smith, the guy I showed at the beginning. He's down at Dark Ridge Observatory in New Mexico. He just is a really good physicist. Has some helpful comments. It also really helps to have college credit. This gets the students excited about the project, and it makes them really engaged and wanting to go for it all. I had a bit of a problem at Chico State while I was there with those high school students because they didn't get any college credit for it. So with Russ's class, it's these high school students taking a college course. So if you can work that in, that really helps. It also really helps to let the students repeat the course. That way you build up a core group of students who come back every year and they become team leaders, and the other ones can kind of build synergistically off of their knowledge, which is really cool. So I unfortunately don't know the exact number of papers that have come out of all these seminars, including the variable stars and other things, because I've only been a team leader and co-author on 31 of them. And I happen to know of a lot more, so I know that it's over 40 for sure. I went through the JDSO and there are over 40 just there, so that's not bad. Also, I'm not sure exactly how many students have gone through the course because not all of them were, were registered for credit in any way. So like with my Chico High School students, they just kind of showed up. The Victor Valley College students, I don't think that was an official course. And same thing with Pine Mountain Observatory. So I'm not exactly sure how many, but I know that's over 200 by a rough calculation. So that's pretty good. That's a lot of lives that we've impacted. So going from there, we've been very successful with the visual double stars, and there are two advances that have happened in the last couple of years, in the last year really, that allowed us to try to expand to the next level, and that would be Lucky Imaging. So this is the program Reduce right here. That is very easy to use, very user-friendly, that allows us to go through a lot of data in a very short period of time. And it isn't so much a black box as MPO Canopus was and EIP for When. It's just for double stars, so you don't have to learn all the other funky stuff that's going on there. And also, Russ got a new camera, which is really cool. It's a high-speed camera, an Andor Luca S. Was it, Russ? Okay. Just want to make sure I got it right. Yeah, so that's what it's called. And so it's a high-speed camera, so you can take thousands of pictures in a very short period of time. So we were able to do Lucky Imaging with the students, which is really cool, and they learned a whole lot from that, I think. And if you would like to know more, you can go to these various sources. They've got all of our, or at least a lot of the papers in the Journal of Double Star Observations. We have a book that I did with Russ and Vera called Small Telescopes in Astronomical Research that has a lot of this stuff. In fact, it has a paper that's very much based on what I'm talking about here today. Then we've got the Double Star Reader that you've got to put in an order for. It's a must-have for double star researchers, I think, if I do say so myself. And then we've got a small magazine called The Classroom Astronomer that I did an article in that describes a lot of this stuff. And, oh, I skipped Amateur Astronomy. That's another journal that some of you may have heard of. Then we have some of our publications in the Society for Astronomical Science, and we've given presentations at the American Astronomical Society. That's another thing that the students get out of this is, and it's a very important part of the seminar, isn't just the publication, but it's the public speaking, going to a symposium or a conference or something like that, where the students can present their research to the scientific community and get that kind of exposure, which is good for networking and lots of other really cool stuff. So I think I'll leave it at that. Thank you.